Graph Theory and its Applications. I am Dr. B. Gayatri, Associate Professor of Mathematics, Periyar EVR Government College, Trichy. My proposed plan of lecture, I am going to introduce concepts in graph theory such as basic definitions, cut sets, planar graphs, coloring of graphs, matrices of graphs, directed graphs and applications of graph theory. So I shall first say what is the origin of graph theory. Königsberg bridge problem, it is the origin of graph theory. During 18th century, many mathematicians were working on this famous puzzle. So there is a river called Brigel which separates two islands A and B into four land areas A, B, C, D. The problem is start at any one of the four land areas A, B, C, D and walk over each of the 7 bridges exactly once and return to the starting point. Is it possible to go for such a walk? Leonhard Euler on his paper on 7 bridges of Königsberg, he published in 1736. This long-standing problem was solved by Euler in 1736. He converted this problem into a graph model as follows, in which he represents the land areas as A, B, C, D called vertices and the bridges by the edges between the land areas. So in a graph theoretic terms, this problem reduces to finding whether we are able to find a closed walk covering all the edges exactly once. That is, whether there exists an Euler line. Euler proved that a solution to this problem does not exist. This problem is nothing but drawing this figure without lifting the pen from the paper and without retracing the lines. A graph is an Euler graph if and only if all the vertices are of even degree. Now let me say the concepts of graph theory. Concepts, we are going to see the basic definitions, cut sets in graphs, planar graphs, coloring of graphs, matrices of graphs and directed graphs. Introduction. If G is an ordered triple G equal to V, E, F, V represents the set of vertices, E represents the set of edges, F is a function which maps each element of E to an ordered pair of vertices in V. This graph without multiple edges and self loops are called simple graph. The first one contains self loops and multiple edges, therefore it is not a simple graph. The second example is a simple graph. A regular graph. A graph is said to be regular if all vertices are of same degree. Here all the vertices have degree 3, therefore it is a regular graph of degree 3. Finite graph. If a graph contains only finite number of vertices, then it is called a finite graph. The other one is a part of the infinite graph. If there is a path between every pair of vertices, then it is called a connected graph. The other graph is a disconnected graph because there is no path from the vertex F to any other vertices of the graph. Complete graph. If there is an edge between every pair of vertices, it is called a complete graph. The first one is a complete graph, whereas the second graph is not a complete graph because you can see the pendant vertices which are not connected by edges. Cycle. This is a cycle on 3 vertices, 4 vertices and 6 vertices respectively. There is a path on 2 vertices, path on 3 vertices, path on 4 vertices. Eulerian graphs. An open trial containing all edges of a graph is called an Eulerian trial. A closed walk containing all edges of a graph is called an Eulerian trial. A graph containing an Eulerian cycle is called an Euler graph. Properties. A connected graph is an Euler graph if and only if every vertex of G has an even degree and the set of edges can be partitioned into cycles. Hamiltonian graph. Hamiltonian cycle in graph G is a cycle that passes through each vertex exactly once. Hamiltonian walk in a graph is a walk that passes through each vertex exactly once. If a graph has an Hamiltonian cycle, then it is called a Hamiltonian graph. This is an example of a Hamiltonian graph and a non-Hamiltonian graph. And here there is an example for an Euler graph and a non-Eulerian graph. K3 is an example for both Eulerian and Hamiltonian. The graph given here is an Eulerian but not Hamiltonian. The first one is a Hamiltonian graph but not an Eulerian graph. And a famous Peterson graph is neither Hamiltonian graph nor an Eulerian graph. Some graph operations of graphs. The join of two graphs G1 equal to V1, V2 and G2 equal to V1, V2. Denoted by G1 and G2 is the graph G1 union G2. Together with all the edges joining the vertices of V1 to that of V2. So this is a G1 plus G2 graph. And this is an example of addition of a vertex. If we want to add a vertex, we have to add an edge between the vertex V to every other vertices of G. That is called G plus V graph. So from a graph G, we can delete a vertex V. The deletion of a vertex means we have to delete all the edges incident to that vertex V from the graph G. This is G minus V graph. This is the complement of graph. We have to join the vertices which are not adjacent in G. That is called G bar. If G and G bar are same, then that graph is called self-complementary graph. This is K3 graph, this is K3 bar, complement graph. This is K2 and this is K2 bar. K3 bar plus K2 bar is nothing but K32 graph. In general, Km bar plus Kn bar equal to Kmn graph.